Hi everyone. In this video, we are going to implement site-to-site VPN in this packet tracer. So we'll be discussing this. So VPN is actually a virtual private network, and we have covered the theoretical part of these things in our previous video. I'm going to put the link of that video in the description section as well. So VPN is actually a private network over the public infrastructure, and everyone will be using everyone would be using that public infrastructure like internet, and then using that public infrastructure where everyone is using the same network, we want to create a secure channel for our transmissions, secure tunnel for the data which we want to transmit. So for that, we need to establish a tunnel before sending any information. In this video, we are going to explain specifically the site-to-site VPN, that how we configure it. So for example, in this case, we have one site here. So we have, say, this is site 1, and then we have this site 2 here. See here, two sites are there, and on this site 1 we have this router 1. On this side we have router 3. So we want to create a secure tunnel from this router to this router, and in between this routers, maybe we can have multiple routers or public infrastructure there, but these routers will be unaware of this VPN tunnel. So for this, we need to configure this interface of the router, that's router R1 sitting on site 1, and the router R3 which is sitting on site 2. So this particular interface, which is actually the serial interface, we need some commands here to configure this, and for that we have this IPsec protocol, Internet Key Exchange Protocol, to establish or to negotiate the security association between these nodes. So let's start with this one, but for that we need some steps, and we will specifically follow the same steps on both of these routers. We call them peer routers. So this is the definitions of VPN, the private network. We discuss it, but what specific configuration we need? So here this is, we need to configure IPsec phase 1 and phase 2. We discussed the theoretical part in previous video. So in that one, we need to configure IPsec policy, we need to configure pre-shared keys, and then we need to configure IPsec policy there. And then we configure ACL for defining interesting traffic. So it means for specific traffic, this VPN tunnel will be initiated, and this will start negotiating the keys. And then we combine or bind them all together in some specific map. Once we have that specific map, we apply that specific map to the interface. For example, in this case, these are the interfaces of the router. On this interface, we'll apply this one. Once we have applied this one, they'll start creating VPN tunnel for the traffic which we define in this access list. Not this one, but in this one, by using this access list, we define the interesting traffic, and for that interesting traffic, the VPN tunnel will be created. And once we are done with all these steps, we'll see some verification commands in the end. So let's begin. Now to demonstrate the idea of site-to-site VPN, or virtual private network, I have taken a computer network here, and for you can see here we have 3 different networks. First network is 192.168.10.0, so this is first network, and then we have some other network 172.16.0.0, and then we have also the third network, that is 10.10.10.0. So we have these 3 different networks, and we want to create a VPN tunnel from router R1. Say this is router R1, you can see on the left hand side, and on the right hand side we have another router, that is router R3, and we want to create a virtual tunnel from this side on the left hand side and to the side which is on the right hand side. So if I just illustrate the same thing, like we can, if I give it a color, then maybe if I fill in any color here for illustration, let's say we selected this color, and we can say that we want to create a tunnel between these 2 routers. Okay, and And then we have, let's say this is the router, which is some other router, and this router can be actually like in most of the demonstration they show, like this is the router. This can be even the combination of different routers. This can be actually the public infrastructure like internet we have there. But our intention is to create a VPN tunnel between the side on the left hand side and the side on the right hand side. Now for this, first we need to configure these both of the routers so that they should exchange the required parameters for between them. So for that, if I say that what we have, so this I mean what you see here, so this is the IP address of this interface of router R3, and this router 3 is actually connected with this network on the right hand side, and this is also connected using serial interface with the router R2, which is in between there. So this is router R2 here, and this interface of the router, which is basically gigabit Ethernet 0/0 interface. So that's, so you can see here, gigabit Ethernet 0/0 interface that is connected with this router. So we want to configure these two interfaces of the router so that they should be able to create a virtual tunnel for secure transmission of our data, because this is the purpose of VPN tunnel. So for that, first of all, we need to configure this for so that it should accept it. So maybe I have something here already. So what we have done this initial configuration, and yes, if you want to create the same type of network, then I have a second video in which I have created this very simple network. So what I have done, so I have just connected this network with these routers, and these all routers have been configured with the OSPF routing protocol is enabled on those all routers, so they are exchanging this information with each other. And if you want to verify, then for example, if I ping from this PC, so all the PCs on this side, they are in this network 192.168.10.0. So this first PC is 192.168.10.1, and second one is .2, third PC is .3. So in this way, these all PCs are there, and then we have this default gateway interface there. This one is, and if we go on the right hand side, this is the second network. So this is actually, this in between, you can see this is some other network, but we are not interested in that network. We only just want to create a tunnel between this side, which is in green in color, and the side which is in yellow color on the right hand side. And if we want to verify that this all working, then maybe I can ping from this PC. So from this PC, if I go to command prompt and if I ping some of the PC on the right hand side, maybe if we say PC 8, and its IP address is like 10.10.10.3. so you can see this is actually this this network IP address is this one. So from this PC, if I'm going to ping 10.10.10.3, which is the IP address of this PC, so I have assigned these our PC's IP address in this domain. So so let's say if I ping from this PC, see, let's wait. If everything is working fine, then we should be able to get reply back. So you can see after some time we are able to get reply back from that PC. So it means this network is working fine. And now on top of that, now we are going to configure this virtual tunnel VPN. So first of all, we go to privilege mode, and in privilege mode, if we need to verify that if the technology package is enabled, security technology package is enabled or not. So for that, we use this show version command, and by using show version command, if we just click there, place enter there will be a table which will be specifying whether security technology package is enabled or not. So you can see in the second row it says that security is disabled. So for that, we need to enable the security technology package, and to enable the security technology package we need to go to global configuration mode, and global configuration mode we need to issue this command, that is license boot, and then we have module number is C1900, and then we say technology package, and technology package, we have to enable the security K9 there, and we press enter. So this command says that you want to accept this. We say yes, we want to accept it. And now to activate these all relevant things, then we need to reload the router. So for that, we go to the privilege mode. And in the privilege mode, first let's copy these all running config to startup config, enter, and then we just use the command reload, and in this way the router will reload. And next time when the router will be reloaded, it will have this will show that the security technology package has been enabled on this router. Because if you don't enable that security technology package, then all the commands which we need to create a secure tunnel or to enable VPN in between these two sites will not be possible. So if we go to this show version command, and if you see, if you press enter, then we should have the same information in that here. So it says, now this says that security, so technology package is enabled there. And now we can issue the commands, required commands to which we require for creating this VPN tunnel between these two sites. So for this exchange of those parameters which we need for creating a secure tunnel between those two routers which are on two different sites, we have to configure the IPsec phase 1, internet key exchange phase 1, and then internet key exchange phase 2. So all the steps we mentioned before. So these have to be configured here. So first one is in the global configuration mode. First we go to global configuration mode, and here first we are going to configure the first IPsec phase, internet key exchange phase 1, and this is also known as IPsec policy. So we are going to configure IPsec policy parameters here. So for that, in the global configuration mode, we have the command crypto and then IPsec and then policy. We are going to define the policy and then the number. So we can give any policy number here. If we can get the help from question. So see, this is the priority of this policy. So we can give it any number. Roughly, we are going to give it a number of 30. And then in this policy, we can configure, or we are supposed to configure 5 parameters. So in general, they are called as Haggle, H-A-G-L-E. So in this Haggle, let's see what we are supposed to configure here. So I'm using the question mark, and the question mark, you can see we can configure, or we have to configure the authentication, encryption, and group, hash, and lifetime, H-A-G-L-E. So A authentication, G group, so group is set the any Diffie-Hellman group, GL is the lifetime for this security associations. These pairs, so router R1 and R3, they are known as pairs, and those pairs will establish the security associations here. So all these parameters we need to configure there. So first we are going to configure the required encryption. So let's say we are going to select encryption, and let's say in the encryption we have different options like triple DES, AES, and DES. So we have these 3 options, and let's say we can select any one, but at the moment let's say we are selecting AES, Advanced Encryption Standards, and then in the AES we can specify the number of bits which we can use there. So we are going to use 256 to make this connection more secure. So this is the encryption. We configure the encryption for, so we are at this router 1. Again, we are at the router 1 on site 1, let's say. So we configure the encryption, and then we need to configure the authentication method, that how these nodes will be authenticated. And for authentication, we are going to say that we will be using pre-shared key for authentication. And then for the lifetime, so for lifetime, let's say how much time, like if we use question mark, so lifetime in second. So this is the lifetime for the connections, so VPN connections, and this lifetime is given in seconds. And let's say we are selecting maybe any number we can select here. Maybe if this is like 36 100 maybe. So this is the live time, but maybe live, and then press enter. So we selected the live, configure the live, and then group. So group is the actually the Diffie-Hellman key by which they exchange, they share, calculate the keys there. So group 5 we can have any group. So 1, 2, 5. So we are going to select group 5, Diffie-Hellman group, and then we say exit. And now we actually configure the key, the pre-shared key, and for that we have the crypto command. So crypto IPsec and then key, and key, say we can use any key. Let's say I'm using newbie123 as a key, which should be same for router 1 as well as router 3. And then we have to give the IP address of the pair which will be used. So in our case the pair is, so pair means the router 3 who is on the opposite side of this router. So in this case pair is 200.176. So let's say that's 200.176.23.2. So this is the IP address of the pair, and then we press enter. And now these were the configuration required for IPsec phase 1 or IPsec phase. And now in IPsec phase 2, actually we have to define the IPsec policy, the policy parameters. So we actually create a transform set, and that transform set we define the encryption as well as the hashing functions. And for that we have a command that is crypto, and so we say crypto and then IPsec, and then transform set is the keyword. So we are creating the transform set, and then we can give any name to this transform set. Maybe we can give name like my, and my like transform set. So this is the name of the transform set. And then in this transform set, what we can configure, like the encapsulation protocol. So let's say we are using encapsulation protocol ESP, encapsulation security, payload protocol ESP, and then encryption. So we are using, for instance, advanced encryption standard, so AES. And then we also need to configure the hashing there, and for that we again say encapsulation security ESP, and then we can say we can select, even we can, if again use a question mark, you see we can have these different options. We are going to select maybe ESP SHA and HMAC. This will be our hashing algorithm which will be used there. In this transform set, that's IP security policy, second phase of IPsec. Now the important thing is also that this tunnel, so between router R1 and R2, the tunnel will be created, but the tunnel will be created for some specific traffic. We call that interesting traffic. So it means this tunnel will not be created for all of the traffic which will be flowing from router 1 to router 3, or maybe site 1 to site 2. I can also give it a name like this is site 1, and let's say, so this is site 1, and if I copy and paste this one, so this site 1, and this is actually site 2. So not for all the traffic which is flowing from site 1 to sites 2, this tunnel will be created, but this we need to define some specific traffic for which this tunnel will be created, and we call that traffic an interesting traffic. And to define the interesting traffic, we actually use access list. So for that, in the global configuration mode, we are going to configure that the traffic from this network in green color, so 192.168.10.0, that traffic from this source going to destination, that's 10.10.10, that traffic will be classified as interesting traffic. But any traffic which will flow from this maybe 192.168.10.0, and this will go to 172.16.0, so that traffic will not be considered an interesting traffic, and for that traffic no VPN tunnel will be created. Okay, so it means we are interested in creating tunnel from router 1 to router 3. Okay, so for that we are going to define the interesting traffic, and for that we need to go, we are already in the global configuration mode, and for that, for extended access list, we can use any number here. So, and then we are going to permit the traffic with IP protocol, and the source network is 192.168.10.0, and then wildcard mask, that is 0.0.0 or 255. So this is the source network, and the traffic going to the destination network having this 10.10.10.0. And then we were only interested in checking the first byte, so I could have used just 10.0.0, but it's okay. So 0.255.255.255, this is the wildcard mask. Roughly it will check only the first octet of this IP address. So this is the destination network, and in this way we have defined an access list which will permit the traffic from this to this, but we will use that access list as a filter which will filter out the traffic, interesting traffic, which will define the interesting traffic. So once we are done with all these things, we need to combine them. We need to bind all these phase 1, 2, these all parameters and this access list in a crypto map. And in that crypto map, we actually bind these all parameters, and once we have defined that map, we will apply that map to some particular interface. So we are going to combine these in a crypto map, and for that we have a command that is crypto map, and then maybe we can give it a name. So my and this can be VPN, and then we can say map, my VPN map, and then we can define a number here, and then we have this IPsec, and then we will move to this map configuration mode. And in that mode, we say that will be the pair. So we configure the pair, or we define the pair. So pair will be that interface of the router, that the router is R3. That R3 will be the pair. So we are going to give the IP address of that router. So that is 200.176.23.2. So this is the IP address of this interface. You can see here. We define this one, so that will be our pair, and then set the transform set. So for the transform set, what name we use, if we use here, see what was the name. Transform set, the name was my transform set. So I'm going to copy this name here. So set transform set. First, we need to give the keyword of transform set and then the name of the transformer set we defined before. So this is the name we use there, and then we have to match the address. Match address means this is the access list which will be used. So access list defining the interesting traffic for which we want to create the tunnel. So that access list number was 120. We define it, and so that is match address, and then we can add it there. So now on this router, we have configured everything we need. So I phase 1, I phase 2, and then apply this crypto map to the required interface. So now this interface on the router, the outgoing interface here. So let's see what that interface is, gigabit 0/0. So to apply that, I need to go to that interface, that's gigabit 0/0. Once we are in that interface, we say crypto, we apply this map, the crypto map, and then what was the name of the map? That's my VPN map. Give the name of the map which we created, that's my VPN map. Now we are done with that. So now on this interface of the router R1, which is on site 1, we have configured everything there. Exactly the same configurations are needed at router R3 as well. So for that, first we need to go, let's say we need to go to the privilege mode, and in the privilege mode we need to enable the security technology packet. So we need to check it by using show version command, but we know that we have not configured it. So we are going to configure, enable this technology package. For that we have the command license boot module, and then module name is C, number is C1900, and then we have technology package, and for that security K9. Press enters. We enable the security technology package, and now we need to reboot or reload the router. But first we need to copy this running config to startup config so that we don't lose the configurations. And now we issue the reload command. So we'll just reload this one, and once it is reloaded, the security technology will be enabled, and then we can use all the required commands we need so that these two routers sitting on two different sites, they should be able to create a VPN tunnel. So now for that we are going to configure the IPsec phase 1. So IPsec and policy parameters we're going to configure, and for that we need to go to global configuration mode, and the global configuration mode we have this command, that's crypto IPsec policy, and then we can give any number, even the same number, taking the same number. And in this one we need to select the encryption key. So we are going to select encryption, that will be AES, and 256 is the key length. And then for authentication we are using pre-shared key. So the same commands, the replica of the same commands will be used here. And then we use a live, and for live we say 36. This will be the lifetime for that VPN. And then we, for Diffie-Hellman, we are selecting group 5, and then we exit. And then we need to configure the key for that, crypto IPsec and key. If you remember, we selected the key UB123, the same key is used here, and then the address of the pair. So in this case our pair is this interface, that is 10.20.30.1. so 10.20.30.1. so this is the interface. So at the moment we are at router 3, and for router 3 the pair is router 1, and specifically this interface, giga interface. So this is the pair, and we're done with that. And now for phase 2, that's IPsec phase 2 policy parameters. For that we are going to create a transform set, and for the transform set we are already in the global configuration mode, and we say crypto and IPsec transform set, and in the transformer set we can select any name. Let's say we are going to select say my VPN transform set, or like any name we can give it, transform set TS, let's say. And then we are going to configure this ESP, and this ESP we can select any encryption. So AES we are selecting as an encryption, and then we also need to configure this Diffie-Hellman hashing, hash. So for this again ESP and SHA and HMAC, we are selecting this one. So now we created the transform set. Once we have created the transform set that we did before, now we also need to configure the we need to define that the interesting traffic. And for this interesting traffic we are going to define that any traffic going from this source network, which is site 2, and any traffic going from site 2 to site 1. So for that we are going to define an access list here. The access list again 120, and then IP traffic is allowed, and then we say we are actually configuring this source network. So in this case our source network is 10.10.10. maybe 10.10.0. that's network, and we only have, we need to check only the first octet. So this will be our first octet will be checked. So this is our wildcard mask, and then this will be the source network, and the destination network is 192.168.10.0. but this time these 3 octets should be checked only. We don't care about the last octet. So now we have defined the source network and the destination network with this. So we actually made some mistake. Let's say what So access list 120, and we forgot the keyword, that is permit. So access list 120 and permit, we forgot this keyword, and access list is there. And once we have defined the interesting traffic and we are done with the phase 1 and phase 2, we need to define the crypto map. So for that we have the command crypto map, and then we are going to give the name to that map. So name can be like, again, my VPN and then map. So this is the name of the crypto map, any number there, and then IPsec. So we are creating this crypto map, and in this crypto map we are going to define the pair. So in this case our first command will be set pair, and set pair, so pair will be 10.20.30.1, 10.20.30.1, and then we are going to set the transform set. So the transform set name, what we use the name here, my VPN TS. So this was the name of the transform set we created. I'm going to copy this one and paste it here to avoid any mistake there. So that's the transform set, and then we match the address of the access list we defined. So that was 120. It was the name of the access list we just created, and then we exit, and now we need to apply that transforms this map, this crypto map, to that particular interface. So that interface is basically GS. This is actually serial interface in between them, and if we hover over there, that serial interface is basically serial 0/0/1. So I'm going, so that's not that one. So let's see which one is this. So that's serial 0/0/0. So I'm going to that interface, the interface serial 0/0/0, and here we apply that map. So we say crypto map, and then we give the name of that crypto map. So the crypto map name was my VPN map. So I'm going to copy and paste the same name of the crypto map which I just created on this router. So now with this we have applied this to this interface of the router as well. So we are done with the required configuration on both of the routers, which are on side 1 and side 2. Now we want to verify that whether this has been enabled or not, and for that we can use some verification commands as well. Now it says show show crypto IPsec security association. We press enter here. So now this actually shows that whether the tunnel was created or not, or how many packets were actually encrypted and how many packets were not encrypted. So we have only, you can see, we don't have any packets which were encrypted because no interesting traffic has has been transmitted from this site 1 to site 2. So now if we create this interesting traffic which should go from the site 1 to site 2, then this VPN tunnel should be created, and then we should be able to see something here. So for example, in that case, we are going to create this interesting traffic by pinging, or we use ping command from this command prompt, and if we ping some node on this network. So let's say again we use the same node, and on the network which is on site 2, we are using that 10.10.10.3 node, and we are just generating an ICMP traffic. And so press enter, and let's see when this goes there, and this should be successful. If everything worked fine, then this should create a VPN tunnel there, and it means some data should be encrypted, and like this. We can see after 3 trials, we can see this is ultimately successful at the 4th time. And again, if we use this IPsec security association command, if we say here, say show crypto IPsec security association, and now it should show us that these many packets were actually encapsulated. You can see here. these many packets encrypted. It means now the tunnel was created there, because this number before this was 0. If you again use it second time, the same command, now you can see this is getting reply back. And if I again use the command, same command for show and security association, now you can see that now this time this is showing more number of packets which were encapsulated and encrypted from this the side to this side 2. In addition to that, we also have some other verification commands we can use. For example, show crypto, we show crypto, and we also have IPsec policy, so we can see the policy there. We can see what policy we have, IPsec policy, which we configured in phase 1 Haggle. So see encryption, what encryption we have, what hash algorithm we have, and what authentication method we are using, what Diffie-Hellman. So we can see, we can verify these all IPsec policies with this show command. And then if we want to see the transform set, then again we have the command that is show crypto, yes, show crypto IPsec, and then we can use transform set command. It will display as the transform set which we configured for in the second phase. Here you can see the information here, the ESP AES ESP SHA HMAC which we configured there. So this was some configuration commands when we want to configure a side-to-side VPN between two different sites, two remote sites. And I hope this was a bit helpful for you. And thank you for your time, and hope to see you in some other video. Thank you.